Today we're talking about interpreting graphs. Okay, it's like a graph with a picture on it, and we're trying to see what it says, or we're given a story problem. We're trying to draw a graph that doesn't necessarily just include a straight line that shows or represents the situation. So, the height of a tree increases over time, but not at a constant rate. Which graph best shows this? Now, this one here, this is the height, and this is the time. This is saying over an amount of time, that height never changes. But in our question, or in our story problem, it said it increases. To increase means to grow or rise, or this one, our height, well, as time goes on, it gets higher and higher and higher. So B has to be the correct answer. To fill in our blanks, though, because we want to see what this says, it says, as the tree grows, its height increases, which we know from the problem. And then it reaches its maximum height. There comes a time where the tree is not going to grow anymore, and it just kind of levels out. The A says it was planted and that high, and it never grew. B says it was planted, and as the time went on, it got higher, just like we know trees to do. So, graph A shows that the height of the tree is not increasing, but remaining constant. It never grew, it never shrunk. Graph B shows that the height of the tree is increasing at a constant rate without reaching a maximum height, and so the answer is B. Okay? Jared parked his car in the supermarket parking lot and walked 40 feet into the store to the customer service counter, where he waited in line to pay his electric bill. Jared then walked 60 feet to the back of the store to get 2 gallons of milk and walked 50 feet to the checkout near the front of the store to pay for them. After waiting his turn and paying for the milk, he walked 50 feet back to his car. Sketch a graph to show Jared's distance from his car over time. Use your graph to find the total distance traveled. Now, this is a very, very, very long story problem. So it really helps to understand the problem and to write down everything you know. So the first thing is, what are we answering? Well, it says use your graph to find the total distance traveled. So the answer is the distance that Jared traveled. That says distance. So Jared walked to the customer service counter first. Okay? So customer service. And when he did that, it said he walked 40 feet. So I'm just going to put 40 feet here, so I know how far it was. Then Jared stood in line, waited in line, one of the two. And then he walked to so we have, he parked his car, we have the walking 40 feet, where he waited in line to pay his electric bill. I'm just going in order. Then he walked 60 feet to the back of the store. So at the end, I'm going to put 60 feet so I know how far it was. So I'm going to cross that part out because I used it. Then he walked to the checkout. And it said it was 50 feet to the checkout. So now we can cross that part out. After waiting his turn to pay for the milk, he walked back to his car. So first he waited in line, and he walked back to his car, which says it was 50 feet back to his car. Okay? So we have everywhere he went and how far it was to each one of those places. Now we're going to sketch a graph to see the total distance that Jared traveled. So we're going to go to a different place to do that. Hold on. But before we sketch that graph, let's look at filling in the rest of this because we already have our numbers. So the distance increases as Jared walks to the customer service because he gets further from his car. If he gets further from his car, it increases. If it gets closer to its car, it decreases. The distance blank when Jared waits in line remains the same because he's not going anywhere. The distance blank as Jared walks to the back of the store. Well, the back of the store is going to be further from his car, so we're going to say it increases. And then he walks to the checkout. So as he's walking to the checkout, it decreases because he's getting closer to his car because we're assuming, based on the problem, that the checkout's in the front of the store. Usually is. Then while he's waiting in line to check out, his distance remains the same. And then the distance decreases as Jared walks back to his car because he's getting closer to his car. Now, those words, and the reason we filled that out before we drew our graph, is it helps us know how to draw our graph. Okay? So now, in this little box, we're going to draw. The bottom's going to be time, and the side's going to be distance. We don't know anything about the time, but we know the distance started at 0, and we know we have some numbers we can apply to it. I'm going to put mine by 20s. Okay, so Jared started out at his car, so at 0, and he walked 40 feet to the customer service. Then he waited in line. Because he waited, the distance remained the same. So we're just going to draw a straight line, which means he didn't get further or closer, but he did use time. Then he walked 60 feet to the back of the store. He grabbed his milk, and then he walked the 60 feet to the front of the store, where he waited in line again. So back of the store, we got further away from his car, so we increased. Then he went to check out. So it decreased because we got closer to his car. Then we had to wait in line, so it was a straight line because we didn't get farther or closer to his car, but we did use some time. And then he went back to his car. So we're starting back at the 0 distance because of the fact that that's 0 feet is where his car is. So the distance increase from 0 to 100, our top point was at 100 and back to 0. Okay, so the total distance was 200 feet because he went 200 feet or 100 feet away from his car and then 100 feet back to his car. The graph is reasonable because it pictures someone walking away, standing still, walking away, walking back, standing in line, and walking back. The distance is reasonable because Jared was 100 feet away from his car at his furthest point. Then he returned to where he started. So do the check it out. All you're doing is telling me which answer or which graph answers that question, graph A or B. And I would also like you to give me kind of a why you know that on your answer. Don't just put A or B because you got a 50-50 shot. I want you to have some type of written explanation of why you know that's the answer, so I know you know what you're doing.